Last class we talked about the calculation of the moment of inertia of different objects, discrete particles, linear object such as rod, the ring, the aerial object or laminar object called disk, then solid objects like sphere and cones. This class will discuss the moment of inertia calculation by applying two different theorems called parallel axis theorem and perpendicular axis theorem. In parallel axis theorem, let us assume that an axis is given which passes through the center of mass, and moment of inertia about that axis is known. How to calculate the moment of inertia of the rigid body about another axis which passes through some different point of the rigid body and parallel to the axis which passes through the center of mass of the rigid body? That is called parallel axis theorem, which states that in a rigid body, this is the center of mass, an axis which passes through the center of mass, the moment of inertia about that axis, let it be IC. You take another point P, let an axis or a straight line passes through that point, and the moment of inertia about this axis which is parallel to the centroidal axis. This is an axis parallel to the centroidal axis. Let us assume that the moment of inertia about this axis be IP. The parallel axis theorem states that moment of inertia about this axis is equal to moment of inertia about the centroidal axis which is parallel to this axis plus the mass of the object into the shortest distance between these two axes, square of that. IP is equal to IC plus MR square. To prove it, we have to take the left hand side, this is IP. Moment of inertia of the rigid body about this axis is called IP. moment of inertia of the rigid body about the axis number 1. And I say is the moment of inertia of the rigid body about center of mass axis, that is called 2. We can draw the diagram in different way. Let us take this point P and center of mass point, and imagine that the axis is z axis, or the axis is normal to the board passing through these 2 points. These 2 axes are parallel axis. And you put the axis like this, which passes through the center of mass C. Another axis like this, which passes through the point P. These 2 axes are parallel axis because these 2 axes are perpendicular to the what? The whiteboard. So this diagram can be drawn in this way. To calculate the moment of inertia about this axis, let us take a particle at a distance of, suppose, at this. Let us assume that the distance between these 2 axes is r, and the position of this element of the body with respect to this axis passing through the center of mass C be say r1. To find the moment of inertia of the rigid body about this point or this axis P can be written as Ip is equal to integral r square dm. We know that r dash is equal to r plus r1 according to triangle law of vector addition. Therefore, r dash square equal to r square plus r1 square plus to r dot r1 vector. Vector A plus vector B, square of this equal to a square plus b square plus 2a dot b. Now you can substitute r dash from equation 2 in equation 1. Putting r dash from equation 2 in equation 1, we have Ip is equal to r square plus r1 square plus 2 r dot r1 into dm, integration of this is equal to r square dm integration, then r1 square dm integral plus 2 r dot r1 dm integral. You can pull 2 is a constant quantity and this is a constant quantity, the distance between these two axes, that is r, out of the integral in the next step. R square dm, in this term r is a constant quantity. What is r? Distance between two parallel axes. P and C. This is a constant quantity. Pull it out of the integral to get r square integral dm. Come to the second term. R1 square dm integral. Since 2 and r, these two quantities are constant and dot product is there, you can pull it out along with the dot. And the variable r1 vector dm will be there inside the integral. And this term gives us the total mass of the rigid body. Let it be m. And this term gives us the moment of inertia of the rigid body about the central axis, about the center of mass axis, because r1 is the distance of the particle, of the element, of the rigid body, that is dm, with respect to the central axis or center of mass axis. Therefore, we can write it IC. What is IC? R1 square dm integral. R1 is the distance of the elements from the center of mass axis. This is the moment of inertia about center of mass axis. Let us treat the third term. R1 dm integral. This is called the first moment of mass. m1 r1 c plus m2 r2 c plus mn rn c is equal to 0, or you can just write mi ri c, the sum of the product of mass and the position vector of the particles with respect to the center of mass is always 0. Already we talked about this principle. This is one of the property of center of mass in discrete particle system, discrete mass distribution. For continuous mass distribution, when the mass is uniformly distributed or non-uniformly distributed, doesn't matter, but it must be continuous. Instead of mi, we can write dm. Instead of the position vector of the ith particle with respect to the center of mass, we can write r1 vector. Instead of summation, we can write integration will be equal to 0. Therefore, this term will vanish. Sum of the first moment of the elements about the center of mass is always 0. That is a property of center of mass. As a result, we are left behind with two terms, mr square plus IC, or you can just write IP is equal to IC plus mr square. This is what we call parallel axis theorem, which states that the moment of inertia about any axis passing through a point of the rigid body is equal to moment of inertia of another axis which must be parallel to the given axis and must pass through the center of mass plus mass of the rigid body plus mass of the rigid body into the square of the distance between these two axes. This is what we should remember as parallel axis theorem. And using this theorem, we can solve many interesting problems. Let us take an example of the rod. This rod, unless it is stated, this is a uniform rod. This is the center of mass axis C. Suppose this is the end point. You can take two axes, two parallel axes along z direction. If you take this is x, this is y. This is one axis, this is another axis, two parallel axes. IC is equal to m L square by 12. We proved in the last class. PC is the distance between two parallel axes. Then by using parallel axis theorem, we can write IP is equal to IC plus mr square. IC is equal to ml square by 12. M R is equal to, if this is L, for uniform object, the center of mass is situated at this geometrical center or midpoint of the rod. Therefore, this R is equal to L by 2. You can substitute R as L by 2 here. Then you can sum it off to get ml square by 3. By the process of integration, by using the basics, you can get the same answer as we proved in the last class. Let us take another example. You take the disk. Let the radius of the disk be r and its mass be m. About the center of mass axis, which is lying along the z direction, this is x, this is y, this will be z direction. This is center of mass C, this is another point P. How to calculate the moment of inertia about this point or about the axis which is parallel to the centroidal axis? You have to use parallel axis theorem. IP is equal to IC plus mr square. R is the distance between two axes. Here IC we have calculated in the last class as mr square by 2 for the disk, and the distance between these two axes is none other than the radius of the disk. So if you substitute IC is equal to mr square by 2 and small r as capital R, the radius, we are getting 3 mr square by 2 for uniform disk. If we take a point, suppose Q, and imagine an axis passing through this point which is lying parallel to the z axis, then we can say that IC and IQ are parallel axis. How to calculate the moment of inertia about this axis? According to parallel axis theorem, IQ is equal to IC plus m QC whole square. If the distance is given as r by 2, say, then substitute IC as mr square by 2 and QC as r by 2 when it is given. So mr square by 2 plus mr square by 4, this will give us 3 mr square by 2. Mr square by 2 plus mr square by 4, that is 3 mr square by 4. Answer. In this way, if moment of inertia about the center of mass axis is known, then we can calculate the moment of inertia about any axis parallel to the center of mass axis. That axis may pass through the body or it may pass outside the body. Let us take another problem. You take a solid sphere. You take an axis outside the solid sphere which is at a distance of r from the periphery, where r is the radius of the solid sphere of mass m. How to find the moment of inertia about this axis? For this, imagine an axis which passes through the center of mass and is parallel to the given axis. This center of mass axis. Parallel axis theorem says that IP is equal to IC plus m r square. What is r? The distance between these two axes. We know that about the center of mass axis, the moment of inertia of the sphere is equal to 2 by 5 mr square, as we have done in the last class. And the distance between these two axes is equal to 2r. You substitute these two values to obtain IP is equal to 2 by 5 mr square plus m square of 2r. This is equal to mr square, you take common, 2 by 5 plus 4. That is 22 by 5 mr square. If you take another axis which is parallel to the centroidal axis and passing through this point, suppose M. How to find the moment of inertia about this axis which passes through M? Apply parallel axis theorem, which states that Im is equal to Ic plus M into the distance between these two axes. Ic is equal to 2 by 5 mr square, and the distance between these two axes in this case is equal to the radius of the sphere. This will give us 7 by 5 mr square. This axis is outside, this axis just passes through the periphery of the solid sphere, or we can say it is tangential to the, it is just a tangent to the solid sphere, it is a tangential axis. Another axis you can take inside at a distance of say r by 2 from the center, let it be passing through n. Moment of inertia about n, the axis passing through n and parallel to the centroidal axis, is equal to Ic plus m nc whole square. Ic is equal to 2 by 5 mr square plus m, nc is equal to r by 2. So you are getting mr square, you take common, 2 by 5 plus 1 by 4. 8 plus 5, that is 13 by 20 mr square. This is the answer. So it may be outside axis or just touching, or it is tangential axis, or it may be passing through the body. It doesn't matter. In all the cases, using the parallel axis theorem, you can calculate the center of mass about all these axes. You can calculate the moment of inertia about all the axes.